Okay. So now I want to see what kind of image, oh my, oh that's awful. I want to see what kind of image we create if I put the object close to the mirror. And remember, that was my little orange guy. I put him close to the mirror, and the image was upright and magnified. You know what? I think I'm going to need a little more room. I'm going to redo. Mulligan. Right? Golfers? Taking a mulligan. Yep. Okay, so there's my focal point. Now I'm going to put my object really close to the mirror. But I follow all the same rules. They're just a little trickier this time. So parallel light exits through the focal point. So the only way I can do that is to kind of go through the object, right? Like that. Parallel light exits through the focal point. Light that goes through the focal point exits parallel. It's the same rule, but just flipped. Now, it's kind of hard to go through the focal point. If I went this way, then I would just be sort of going on this same light ray backwards, and that's not going to help us. We need at least two intersecting light rays to create an image. So instead, I'm going to aim my light ray through the focal point, like this. So aim the light ray through the focal point and exit parallel. Got it? So where will these two light rays meet? Behind the mirror in virtual land.
So if two rays don't meet in real land, they'll meet on the opposite side. But if they meet in future, okay. So if they don't meet in real, then they will meet in virtual.
Correct.
If they do meet in real, then they won't meet in virtual.
Correct. Wow. All right, Wes. You got it right, and you still say it's stupid. All right. So those are going to meet behind the mirror in virtual land, and it's magnified, right? It's much bigger and upright, which is what we saw. Okay. Now, there are a whole bunch of rules that apply to this. Not only this is like the drawing part of it, but then there's also a bunch of rules that apply, yes, there they are, to curved lenses and mirrors in terms of assigning positive and negative values. Now, I'm not going to make you memorize this chart, but you will, because you will understand. Okay? So if you look at this, what happens is anytime you see, so this is the one we just drew is a concave mirror object in front of the focal point. The image distance is negative. The reason the image distance is negative is because it's a virtual image. So if you can draw it, then you don't have to memorize all this. You just have to know virtual images are negative images. Real images are positive images. Upright is positive. Upside down is negative. The rules make sense, okay? And then this is a magnification issue. Magnification is either greater than or less than 1. So if I have a really big image, would you say that's a magnification greater than or less than 1?